So now let's continue on and go forward, introducing us to the t-test. So what's different about the one sample t-test when compared to the z-test? The standard deviation. In the z-test, the standard deviation is provided, but in the t-test, it's not known. We have to estimate the variance for population based on the sample variance. Secondly, the cutoff point is going to be different. In the z-test, we use standard cutoff points based on the z distribution. We looked those up, you'll remember. But in the t-test, we're still going to be looking up cutoff points, but we'll be using a t distribution, and we'll be basing it on alpha and something called degrees of freedom. And thirdly, the standardized score, you already saw that it's the same, which it is. In both cases, z-score and t, it's sample mean minus population mean divided by spread. But the symbol for spread is going to be this thing called SM instead of sigma m, because we calculate it differently. So we already know from the previous content that the t distribution looks a little bit different because it's kind of fatter in the tails if we have lower numbers in the sample. So for that reason, we calculate the spread standard deviation a little bit differently. So the standard deviation isn't known, and since we don't know the standard deviation, we have to estimate variance for the population based on variance from the sample. And there's lots of evidence from mathematicians that they're going to be approximately the same, that if you draw a sample of enough people from a population, you're going to get a variance that's about the same as if you knew the variance for the population. So instead of calculating variance using, you might recall this or might not from chapter 2, but we divide the sum of squared deviations by n. That's what we've done in the past in chapter 2. But now we have to estimate it using the sum of squares divided by n minus 1. We call it, in our class, I just call it EVAR. There are other ways of referring to it. I think they're confusing, so we're going to name it EVAR, the estimated variance for the distribution of means. For the distribution, excuse me. And so instead of calling the standard deviation sigma, like we do for a population where it's really vast, like how we know people's body temperature, or SD, which is what we did in chapter 2 when we were just calculating the standard deviation for a small set of numbers, we call it S. And when we italicize this S, it means we've estimated the standard deviation from the sample. So let's use this situation to work through this. So a researcher was studying how hopeful people felt after a devastating flood in their small rural community. She selected 10 people from this community to complete the 7-point hopefulness questionnaire, and she recorded their scores. She wanted to know whether the scores would be higher or lower than the neutral point for the scale. She knew that hopefulness for people in general without a flood was 5. So here's the hopefulness scale, and here's a sample item. I feel optimistic about the future. So we're going to go on and calculate out the estimated standard deviation. So these are the calculations to find spread in a one sample t-test. You'll see here the hopefulness scores that we described in the last sample. So the first thing we do is find the sum of squares. And you might recall, as we just went over, that sum of squares is abbreviated SS, and that we calculate so the formula is SS equals all the deviations x minus m divided by, x minus m squared. And so we're going to, first thing we have to do is find the mean by summing the scores and dividing by n. And so I did that. I summed up all the scores and I divided by n, and I found out that the mean was equal to 5. I also am going to record the number in the sample. I can see that there are 10 people in the sample. And we're also going to need the degrees of freedom for estimating. And I can see the degrees of freedom are 10 minus 1 equals 9. So now let's go on and calculate our deviations. X minus m. So we'll take 5 minus the mean is 5 equals 0. 2 minus 5 equals negative 3. 4 minus 5 is negative 1. 6 minus 5 is 1. 5 minus 5 is 0. 2 minus 5 is negative 3. 3 minus 5 is negative 2. 3 minus 5 again is negative 2. 4 minus 5 is negative 1. And 6 minus 5 is 1. Next, we're going to square these deviations. I'm going to draw a line here so we're clear, which is just x minus m squared. And we've already calculated x minus m, so all we have to do is square it. 0 squared equals 0. 3 squared is 9. Negative 1 squared is 1. 1 squared is 1. 0 squared is 0. Negative 3 squared is 9. Negative 2 squared is 4. 4, 1, and 1. Now we're ready to find the sum of squares. So the sum of squares is just the sum, I'll write SS there, is the sum of all those squared deviations. This is our squared deviations column. So we get the sum of squares by adding all of those up. And I have already done that in a spreadsheet. So I'm going to pull that up. And if we add up all those deviations, we get 20. To get my pen back here. 20. All right, so now this is what we've done, these 3 steps here. We found the mean, we found the deviations, x minus m, that's in column 2. We squared the deviations in column 3. And we have to find the degrees of freedom, n minus 1, we've done that. And here, I see that I didn't write that we have to sum, I'll write it here, and sum the column. We found the degrees of freedom. Next, we estimate the variance using SS divided by degrees of freedom. And again, as you saw in the previous chapter, that allows us to have a variance that's unbiased. And so let's go and calculate the estimated variance. I call it EVAR. It's easier than what your book calls it, which is using that S squared, which I've always found confusing when you're just beginning in stats. So EVAR is just SS, and instead of dividing by n to get variance, we divide by degrees of freedom. And if we do that, we get 20 divided by 9, and that comes out to 2.22 repeating. So our next step is to find the variance for the distribution of means. So we do this exactly the same as we did before. This is no change. Variance for the distribution of means is just EVAR divided by n. We used to do VAR divided by n. Now, because we've estimated the variance, we just do EVAR divided by n, and we find that we get 0.22. And finally, the standard deviation for the distribution of means is just like before, the square root of VARM. And let's phase that in here, the square root of VARM. And so we get 0.47. And that's calculating spread in the one sample t-test. So in summary, spread in the one sample t-test is indicated by SM, this should be in uppercase M, instead of sigma M. The formula for calculating spread in the one sample t-test is just the same as calculating standard deviation back in chapter 2, but we find the variance, which we call EVAR, by dividing SS by DF. EVAR equals SS divided by DF instead of dividing by N. We call this estimated standard deviation S, italicized there, instead of SD like we did in chapter 2, or sigma like we did when it was just known. We call the estimated variance EVAR, but we could also call it S squared. That's what your book does. We call the estimated variance for the distribution of means VARM, the same as we did before, but technically we could call it EVARM. And your book calls it, using symbols, your book calls it S, referring to that estimated standard deviation, S squared, referring to variance, which is what we do to get the variance, and then this M down here. So the variance is S squared, and this M means for the distribution of means. It's hard to type on a keyboard, and it's sometimes confusing for students, so we're going to just use VARM or EVARM. Either one would be okay in this case. All right, hope all this was helpful.